Simultaneous linear and quadratic equations, written and presented by me, John LeGuay. Here's the legal stuff. We want to be able to solve simultaneous linear and quadratic equations. What that means is, if you have a straight line like this, in this example y equals 0.5x plus 5, and you have a quadratic equation such as this one, where y equals 0.25x squared minus 0.25x minus 3. I want to solve those two equations, which means I want to find the 2 points at which they meet. They don't necessarily meet. They might meet at 2 points, they might meet at 1 point, or they might not meet at all. So I want to see where those two lines cross. Simplest way, of course, is just to draw a graph of the two lines and see where they cross. It's quite an accurate way of doing it, but we can do it with more accuracy using equations. So we'll have a look at the equation method. Firstly, you write down your two equations. That's the equation of the straight line, y equals 0.5x plus 5. And that's the equation of the quadratic, y equals 0.25x squared minus 0.25x minus 3. At the points where they cross, both of those equations have got the same x value and the same y value. So you can say that y equals y. That's not very helpful. But you can say that the other parts of the equations also equal. So 0.5x plus 5 equals 0.25x squared minus 0.25x minus 3. I can rearrange this to be everything equals 0. And I end up with this, simplifying down, I end up with 0 equals 0.25x squared minus 0.75x minus 8. That is another quadratic because it's got a squared as the highest power of x. If I was to make that y equals 0.25x squared minus 0.75x minus 8 and then plot it on my graph, I'd get this. Well, that's interesting, but what I'm really interested in is the points at which y equals 0 on that line there, on the x-axis. These 2 points here. The reason why I'm interested in those 2 points is because those two x values are the values where the other two lines intersect. So if I can find those two x values, I can find the x values of the intersections. Now those two x values, of course, are the roots of that second equation. Here's that second equation, and I'll find the roots. I'll use the magic formula. First thing I'll do is I'll check to see if it has any roots. So I check to see if b squared is greater than 4ac. And when I do the calculations, I find that b squared is greater than 4ac. We have 2 roots. If there are no roots, there's no point in carrying on, because there's no intersection. I take this equation and I just plumb the numbers into the magic equation, and out pops, when I do the calculations, out pops 2 numbers. When it's plus, because it's 0.75 plus or minus square root of 8.5625 all over 0.5. When it's 0.75 plus, the answer comes out as x equals 7.3523. When it's 0.75 minus, the answer comes out as minus 4.3523. These are the two x values where the lines intersect. To find the y values where the lines intersect, I'll just plumb those back into the linear equation because that's the simplest one. Plumb those numbers in and I get y equals 8.6762. So the first point where they intersect is 7.3523, 8.6762. Doing the same with the other x value, plumbing that into the linear equation, and I get the y equals 2.8236, and that's the second point of intersection. Here's another example. If I've got y equals x plus 2 as the linear equation there, and y equals x squared, as the quadratic. I could do it from the graph, and looking at it from the graph, I think you'll see it, one of the interceptions is at -1, 1, and the other one is at 2, 4, roughly around those numbers. Let's check using the equations. There's the linear, there's the quadratic. Make the two equal to each other, because at the points of interception, the x and y coordinates are the same. Rearrange to give us a second quadratic, and solve that. First thing we do is we check to see if there are roots, and when we put in b squared and 4ac, we find that there are 2 roots. Then we plumb the numbers into the magic equation, and we end up with x equals 1 plus or minus square root of 9 all over 2. So I'll take the 1 plus square root of 9, and it comes out as 2, and 1 minus square root of 9, and that comes out as -1. So the two x coordinates are 2 and -1. Now I'll find the y coordinates. I'll use the linear equation again, plumb in the 2, and I end up with y equals 4. Plumb in, so the first point is 2, 4. Plumb in the -1, and I end up with y equals 1. So the second point is -1, 1, which was the same as what I found on the graph. So in summary, you make both equations equal and put them together. Then you rearrange them to make a new quadratic equal to 0. You find the roots of the new quadratic, that's when y equals 0. So you find the x values, then you put the x values into the linear equation to find the corresponding y values.